How are y'all doing? This is a video that's going to continue from our past video. It's a continuation of our past video where we talked about our base functions in an idea to determine what happens when we transform them given different characteristics of our equations. So the first type of transformations that I like to discuss are vertical transformations. And every time we see the term transformation, this is synonymous with the term shift. So if we have a vertical shift, that is also the same thing as saying that we have a vertical transformation. Sometimes you're going to hear the term translations, but all of that is going to be synonymous. So it doesn't really make a difference. Translation, transformation, and shift all mean the exact same things. So let's go ahead and discuss a rule. Let's go ahead and discuss a rule for vertical shifts. So we'll say given f of x is a base function. So we discussed some of those in our last example, like square root of x, or absolute value of x, or even x squared, or a value of x. Each one of those are base functions. A vertical shift will occur for any value of b being greater or equal to 0 following the constraints below. So we're going to see a vertical shift up when the graph of f of x equals to f of x plus b. A vertical shift up will occur b units. And I know that seems funny now, but wait till we do an example. And then for the second circumstance, the graph of f of x equals to f of x minus b, a vertical shift down, vertical shift will occur down b units. So I think that the vertical shifts tend to be the easiest to identify. They tend to scream to most people. I know they scream at me. So let's go ahead and see if we can identify a graph that has a vertical shift and which way it will occur. So let us say I just said to examine f of x equals to x squared minus 2. So we recognize that the base function is our value of x squared. And this negative 2 right here, because it's separate from your base function, your base graph is going to be the vertical shift. And that's going to be down 2 units. It's going to be down 2 units. So if we were to examine our base function, so I'll do my base function in red. So our base function will look something like this. Well, as symmetric as I possibly can make it. And this is f of x equals to x squared. Then I know that I would no longer have my vertex, or that bottom portion of the parabola, that it would no longer exist at 0, 0. It would actually shift down. It would actually shift down 2 units because there is a vertical shift down 2 units. So we would have this function like such. So there would be a vertical shift down 2 units. So that's an example of where we're going to see a vertical shift. And again, that can occur with any base function. It doesn't necessarily have to be a parabolic. It could be linear. It could be square root. It could be the absolute value function. It can occur with any one of the different functions. So now let us talk about a horizontal shift. Let us talk about the horizontal shift. A horizontal shift. And I always like to give an analogy of my parents. My parents have been married for quite some time, close to 40 years now. And I noticed, I think one of the reasons why they get along so well is because they always disagree. They always find room to not argue, but maybe bicker, dialogue, debate. My dad could tell my mom that he thinks the sky is blue, and my mom will come back and she'll say, "No, Rick, it's not blue, it's light blue." You know, they will find any reason not to agree. So I know that's a little bit more of what you expected to find out about my family, but I think that may help when it comes to identifying your horizontal shift. So let us say for any d greater than 0, so any d value greater than 0, we'll say the graph of f of x equals to f of x minus d will be the base graph of f of x shifted, and be careful here, I'm going to do this in blue so we can see it, this will be right d units. This will be right d units. So notice the sign is a negative and then it shifts the opposite way. So sort of like, you know, the way that I look at this is I see these set of parentheses here. I think parentheses are like a marriage, and I think of the x being my mom and the d being my dad, and whatever one does, the other does opposite. So they're in marriage, and if there is a horizontal shift, you're going to see a set of parentheses. They're going to be grouped together, and they're always going to have a horizontal shift opposite the sign. So in the second circumstance, the graph of f of x equals to f of x plus d will be the base graph of f of x shifted opposite the sign, so it's going to be shifted left d units. It's going to be shifted left d units. It's going to be shifted left d units. So let's go ahead and analyze an example of where we would see a horizontal shift. So let us say we examine the example, f of x equals the square root of x minus 3, So a lot of times in textbooks or problems, or you're working through an exam on a paper, those parentheses don't follow in the square root, but they're automatically assumed to be there. So notice, this is very different. This is very distinct. This is very distinct from the function f of x equals to the square root of x minus 3, where the minus 3 is on the outside. So I will tell you that this will indicate a vertical shift because that minus 3 is on the outside of the square root. However, this, since they are attached, they are underneath that square root sign, this right here, there will be a horizontal shift 3 units, and notice it's always opposite because they're married, 3 units to the right. So there's going to be a horizontal shift 3 units to the right. So if we were to do a quick graph of my base function, this would be my base function, the square root of x. So this would be f of x equals to the square root of x. And then I have a horizontal shift 3 units to the right, so I would now start at 1, 2, 3 to the right, and it would look something, oh, that's not very good. It would look something like that. So that would be the square root of x minus 3. So let's say on the same graph we wanted to graph the function above. F of x equals the square root of x minus 3. This would be a vertical shift down 3 units. So here we would no longer start at 0, 0. We would start at 0, 1, 2, negative 3. So that would open up like such. So this would be a vertical shift down 3 units, and this would be square root of x all minus 3 at the end. So each one of those has a very distinct transformation, so you have to pay key attention. That right there are some examples. Those right there are some examples we're going to see with vertical shifts and horizontal shifts. In the next video, we're going to talk about rotations about the x-axis and the y-axis. So if you need to practice some of these, I'd recommend doing it because this tends to be one of the more confusing areas of this course. However, it can be mastered with some practice.